Welcome back, reinforcement learning. This session I explained inverse dynamics prediction. Okay, inverse dynamics prediction. This is a part of the intrinsic curiosity model. Okay, in reinforcement learning. Inverse dynamic prediction is a crucial concept in reinforcement learning that address the challenges of predicting the actions based on the state transitions. Okay, this is the focused on the state transition based learning. Okay, this approach is particularly useful in environment where the prediction errors can fluctuate due to the uncontrollable factors like a space rewards. This methodology aims to enhance the agent's ability to learn from its interactions within the states, one state to another state interaction in the environment by focusing on relevant state information in learning process. Okay, the inverse dynamic prediction is the one of the key concept in reinforcement learning in intrinsic curiosity model. In prediction error is the one of the concept in inverse dynamic prediction to predict the to optimize the model performance. The prediction error is a measure of how accurately the model predicts the next state based on the current state and action taken. So the prediction error is we are consider here inverse dynamic prediction how accurately the model predicts the next state based on the current state and action taken on that in a state. High prediction errors can occur due to the random fluctuations in the environment which don't affect the agent's actions. Here, in prediction error case, in inverse dynamic prediction, we are one constant we are using here that does not matter. So, some cases, some events, we are not focused on those states, that is called a does not matter constant. That does not matter constant. To improve the robustness of the prediction error, the model incorporates a constraint that filter out the irrelevant factors. It filter out the irrelevant factors. We remove the irrelevant factors in consideration. So that is the does not matter constant. This means that the model focus on aspects of the state that are controllable and significant to the agent's action, thereby reducing the noise in the performance. So we are not consider the irrelevant factors in model training. Here in inverse dynamic prediction, we are two models we are using in inverse dynamic prediction: forward model and inverse model. The forward model is predict the next state. The forward model predicts the next state. How to predict the next state based on the current state and action happened on that state. We are generally denote the forward model is F, small f. So small f of current state st, action at the time at, I predict the next state st plus 1, s cap t plus 1, s cap is the next state. The next that is the forward model predicts the next state. Inverse model predicts the action. Inverse model predicts the action taken to the transition from one state to another state. It predicts the action, what action we need to transfer to translate from one state to another state, transition from one state to another state. We generally denote that inverse model with the small g. Small g of current state st and next state st plus 1. It predicts the action, which action influence the state to move to the st plus 1. Here we are using the inverse model is trained using the encoded states. Okay, we are using encoded states. Encoded states are the, we get the encoded states with applying the encoder models, which are derived from the encoder model. We are derived from encoded states from encoder models. So the forward model predicts the next state based on the current state and action, and inverse model predicts the action, which action use it to transfer from one state to another state. So forward state denotes with the small f, inverse model represent with the small g. This is the forward model diagram. Okay, the prediction module st and at, current state and current action. We predict the next state st plus 1. This is the inverse model. Inverse model, it is the current state and next state. It predicts the action. Which action leads the transition from one state to state to st plus 1. The inverse model takes the two consecutive states and tries to predict the which action was taken. Next one is the encoder. Encoder state the state into encoded states. The ST and encoder model. The encoder model is pi of ST. We got the pi of ST, the encoded state. After encoder apply, we got the encoded states. The encoder module takes the high dimensional state representation such as the RGB model representation of the state and encodes it as a low dimensional vector. We got the low dimensional vectors. Encoder translation from the high dimensional state into low dimensional representation of the state. Here now we are using the forward prediction module actually uses the encoded states, not the raw states. Encoded states are denoted by the pi of ST. Okay, it's here the pi of ST, the encoded current state. At the action AT, it predicts the next state, next encoded state, pi cap ST plus 1. Here encoded states are we are using in the prediction forward module. In prediction forward module, predict the next encoded state. So this is the curiosity module. Here the encoded function pi, encoder pi, it is a state ST. We apply the encoder, we got the pi of ST, encoder state. The next state ST plus 1, we got the pi of ST plus 1. So the here encoder curiosity model is performed on apply the action on the encoder states. So we got the pi of ST and pi of ST plus 1 after encoders. Apply the encoders on current state and next state. So here the forward model, here we get the forward model take the pi of ST is the input and action AT. It predicts the next state pi of ST plus 1. So here calculate the error function. So here error function is the prediction error. Okay, if the error is it's accurate results, there is no problem. Otherwise, we apply the backward propagation. We apply the backward propagation to the correct next state. This is the forward model. Now come to the inverse model. Inverse model take the pi of ST is the input and pi of ST plus 1. Current encoder state and next encoder states. It predicts the action. Which action leads leads the transition from pi of ST to pi of ST plus 1. Okay, we predict the correct action, there is no problem. Otherwise, we apply the again backward propagation. So these backward propagations are lead to the find out the best actions. Otherwise, we did not get the correct one. Well, again we change the encoder models. So this is the curiosity module with the forward model and inverse model. The forward model predicts the next state, inverse model predicts the action. Which action leads the transition from one state to another state. These are we are using to the states are fluctuated from one continue infrequently. Then we are using inverse dynamics model. The inverse dynamic prediction, the space rewards environment in reinforcement learning present the significant challenges due to the infrequency of the feedbacks from the successful actions. So this we are using the inverse prediction model by inspiring the neuroscience for the predictive coding can be used to address this issue infrequent feedbacks. So we are using the inverse dynamic prediction with the predictive coding. We are find the optimal results in reinforcement learning to solve the complex problems with infrequent feedbacks. Thank you.